Exercise 19 would like us to describe the error in solving the inequality. So it's given us the work of somebody else, and in some place of this they made an error. And so we need to determine where the error was, and it's going to be in either one of these four descriptions here. Maybe in the first description it says that the negative 9 should be divided by a 3. Or in the second description, x should be greater than a positive number. And the inequality sign should not have been reversed. The inequality sign should not have been reversed, and the number should be a positive number. So we need to choose which they did incorrectly. And I tell you guys that the easiest way to do these kind of problems is to actually just do the problem yourself, because the first part is always going to be just the original problem. So you can take that original problem and then determine the answer of that yourself and the steps you would take in order to do that. So let's do that together, and then you can see what we get and compare it to what they got and determine what they did differently, which would be wrong. As long as we're solving it correctly, we're making that assumption that we're correct. So I've got x divided by 3 is less than negative 9. Now I've got the 3 attached to the x. I want to turn that 3 into a 1. And so since that 3 is on the bottom, I'm going to need to multiply by 3 in order to get a 3 on the top. Well, multiplying by 3 over 1 is simply just multiplying by 3, which, as you can see, is something they did as well. They multiplied both sides by 3. So over here, I just want to point out quickly that my times 3 is on the right side, so my order goes negative 9 times 3. Their order goes 3, whoops, what the? Their order goes 3 times negative 9. But because of the associative property of multiplication, you can multiply numbers in any order. It's still the same thing. So don't start thinking that that's what they did differently. I just don't want to move my negative 9 over here. Okay, so now when I do that, 3x divided by 3, I can cross simplify that, and that's going to leave me with just x, is less than, I'm not going to flip the sign because I multiplied by a positive number, not a negative number, and then negative 9 times 3 is negative 27. So now I need to compare how is my answer different from their answer. Well, in my answer, I see that I have a less than sign while they have a greater than sign. That's the only difference that I'm seeing here. Aside from that, the x is the same, the negative 27 is the same, and so you would choose the option that describes that that's the part that they did incorrectly. So I'm going to let you choose that. And then after you do that, you're going to need to correct the error. So we're basically just going to put our work, let me bring our work down. We're going to submit our work into these boxes here. So what did I do here on the second boxes? What number did I multiply by? Well, I multiplied by 3. And then here the sign did not flip on either one of these. But on this little box, it also wants you to put in the number that we got, which was negative 27. So you're going to need to put less than negative 27. It wants you to fill out the whole box. Exercise number 20, write the word sentence as an inequality, then solve the inequality. Ignore this thing right here. I don't even know where that came from. So the word sentence reads that the quotient of a number x and 4 is at most 5. An inequality is, and then we're going to put that word sentence into an inequality. We're going to put it into here, this little box. And then we're actually also going to solve out that inequality, which means we're going to need to solve for x in that inequality. So I just want to remind you that quotient is a division. It refers to division because the quotient is the answer to a division problem. So just keep that in mind. I'm going to write that just so that you can keep that in mind always, because you're going to run into this again. Quotient is the answer to a division problem. So when it asks for, what it's telling you here is that the quotient of a number x and 4, so when we divide x by 4, what we get, or our quotient, our quotient, our answer is at most 5. And so if x divided by 4 is at most 5, that means it can equal 5. And the most it can be is 5. So it can't be greater than 5. It would need to be less than 5. And so that's the inequality that we would need to input into this guy right here. x divided by 4 is at most, that I'm not going to say less than or equal to, I'm going to say at most 5 because it's the same thing. And then I need to now solve for the solution of this inequality, which means to get the x by itself and determine what number is going to go on the other side. Exercise 21 is the same kind of problem. We're going to take a word sentence and turn it into an inequality, and then we're going to solve that inequality. So a number x divided by 7 is less than negative 3. I'm going to actually leave that one totally to you. Exercise 22, write the word sentence as an inequality, then solve the inequality. Same kind of problems for 22, 23. So in 22, we're being asked to turn 6 times the number x is at least 24, negative 24. 6 times the number x, I think you guys all can probably see that 6 times x is the same thing as 6x. I think it'll take it if you put a multiplication sign in the middle, but to be safe, just put 6x is at least negative 24. So what does it mean for something to be at least? Does that mean that it's less than? Is it greater than? Is it less than or equal to? Greater than or equal to? Well, if it's at least negative 24, that means that the minimum that it can be is negative 24, or it needs to be higher than negative 24 because the least that it can be is negative 24. So it can equal negative 24, and then it has to be greater than negative 24. It's kind of like if I told you that I expect at least $20 a day for my work, then that means I expect either $20 or more than $20. So you need to get into the habit of being able to just think through these problems and think through these phrases and determine what are they as symbols and why. Why is at least a greater than or equal to symbol? Well, because at least makes negative 24 the minimum. That's the smallest number that I can have, and so I need to have either negative 24 or all numbers greater than negative 24. So really practice on reasoning through stuff. For exercise 23, the only question I think you may have is what is a product? The product is the answer to a multiplication problem. So what this is telling me is that the product of negative 2 and a number x is greater than 30. This is the product, so that's what goes on the right side. And then the actual multiplication problem that gives us that product of 30 is negative 2 times x. And then negative 2 times x is greater than 30, so you're just going to put a greater than sign and then solve for x. Just want to give you a reminder that you are going to need to consider whether you're going to need to flip the sign, because the number is attached to the x is a negative, and whenever the number attached to the x is a negative, you are going to have to flip the sign. So don't forget to do that.